Okay, good afternoon. Welcome to the seminar. So I'm really pleased to introduce my colleague and a friend, Drew Shindell. And Drew got his undergraduate in physics at Berkeley, his graduate degree in physics at Stony Brook, and then he went on to work at NASA GISS in New York City for about 20 years before he went to Duke. And at Duke, he's a Nicholas Professor of Earth Science. He works on air quality, climate change, and the links between science and policy. He's testified on both issues in the House, in Congress, at the request of both parties. He's developed a climate change course at the American Museum of Natural History, and he's chaired he's chaired the 2011 UNIP WMO integrated assessment of black carbon and tropospheric ozone. Was a coordinating lead author on the IPCC, the 2013 report, and was on the 1.5 degree report. So thanks, Drew, and thanks for the Atkinson Center for making Drew's visit here possible.
Thanks, Peter, for the introduction and for inviting me up here, and everybody for turning out today. So I've titled this presentation, The Social Value of Mitigation Activities, and I have a lot of colleagues, a few of whom are listed down at the bottom here. I want to acknowledge them as well. It's certainly not just my own work. But another title that might be a little more clear-cut as to what I'm talking about, a subtitle, perhaps, is let's explore some simple and not so simple equations and see really what we mean when we give these. So you have all heard, I believe, last week, or at least at the last seminar, about some of the IPCC reports. And going back to the last full assessment cycle, in 2013, we included a picture like this, which was one of the key findings from that report, which was really that you can relate the total cumulative amount of CO2 emitted, right? Because it builds up and just piles up in the atmosphere. Over human timescales, the total cumulative emissions are closely, which is on the horizontal axis, closely related to the temperature change on the vertical axis. All right, so this is really valuable information. This can tell you for any given target, right? You choose your target there on the y-axis and you just read across and it tells you what your total CO2 budget for all time is. This was actually quite politically sensitive because, if you give the entire world a budget, the next logical thing is to divide it up and each country gets an allotment, et cetera. So this led us, hours and hours of debate until all hours in the middle of the night. But it is useful, right? And this tells people a lot about how to deal with climate change. And it tells you that the single biggest, most important thing you really need to worry about is the total amount of CO2 you emit. And so that has prompted a lot of policymakers to, fortunately, take this seriously. Not all of them, obviously. But many around the world are really taking this seriously and trying to control their CO2 emissions. What I want to talk a little bit about today is how, while the headline up there, climate change depends upon cumulative CO2, is true, that's not the only thing that we really care about as a society. And so I want to start with an example of taking this kind of information to heart almost too much, as if this is the only thing that matters. And really, here's an example. In Europe, they wanted to lower CO2 emissions, and the transportation sector is particularly difficult to tackle. So one of the things policymakers put into place in many European countries was a real incentive, an economic incentive to use diesel. Diesel per mile traveled or kilometer traveled in Europe is less CO2 intense than gasoline, right? And so not only to encourage this were economic incentives set, and if you can read that, you can see this is the advertising at a gas station in Germany, and you can see how much cheaper diesel is than the others, right? So economically, the taxes are really lowered. At the same time, the regulations on associated emissions of pollutants are relaxed for diesel. The idea is to really encourage people to use diesel. And so there's been a boom in diesel over the past couple decades in Europe. which has had the desired effect of reducing the net CO2 footprint of the transportation sector. But with all the other pollutants that have come out, it's really caused an increase in smog. And so there's been a big backlash, and the most extreme example is Paris, for example, has said that in 5 more years they will forbid diesel vehicles to enter the city at all, right? Other cities have low emission zones, et cetera. But this is really the problem with focusing exclusively on CO2, right? So we do need to target CO2. We need to try to reduce it. There's a lot of things we can do, but we need to keep in mind that CO2 is not the only thing that matters, and climate change is not the only thing that matters. And so a policy like this one can end up pushing us in the wrong direction, improving climate change in the sense of mitigating some of that change, but at the same time worsening air quality. So we really want to avoid those things. So let's start with the simplest kind of equation. I said there'd be simple and not so simple. This is obviously pretty simple. 2 degrees C equals 2 degrees C. Well, obviously 2 degrees C is 2 degrees. It's just a definition. So why would I even bother to show this? Well, 2 degrees C is the internationally agreed upon target. With the Paris Accord, the agreement is even to shoot for well below 2. But a lot of work has gone into defining what does it mean to reach 2 degrees C. And these scenarios of our possible future, stories of how we achieve these targets by decarbonization, controlling transportation, agriculture, et cetera, these tend to be defined by the climate, the global mean temperature change. So you probably saw plots like this last week when you heard about the 1.5 degree report. This is from a recent study from last year. And it defines a lot of the carbon emissions along the pathway to 2 degrees C. And so if you look closely at this, the green one that's labeled 2.6 watts per meter squared, that is approximately a 2 degrees C scenario. The very low one there is approximately a 1.5 degree scenario. But how are these generated? These are generated exclusively by looking at the climate impacts. So there are, in the background, there's lots of little lines, and there are lots of ways to achieve 2 degrees C. And the implicit assumption here is that no matter how you achieve it, they're all the same, right? So that all 2 degrees C equal all other 2 degrees C scenarios. And in fact, the only thing you try to do here is find the least cost way to get to 2 degrees C. Nothing else matters in these scenarios. They're optimized to get there at the least cost. There's a couple things I want to point out, and I want to focus on the 2 degree, which is the green set there. So it's not the very lowest, but the second lowest thick line. And you can see that the carbon dioxide emissions go negative in that scenario. The net becomes negative around 2075. So that means we're overall taking in more carbon than we're emitting by 2075. But what that kind of doesn't make so obvious, and was illustrated nicely in this paper from a couple years earlier by Kevin Anderson and Glenn Peters, a couple European scientists working on this, was that a typical scenario like the solid line shown there goes negative in the net about 2075. But what you're really doing is deploying lots of carbon dioxide removal technology to compensate, right? That's that pink shaded area that's below the zero line. And you're deploying that to compensate for all the things that are really difficult or expensive to decarbonize that are emitting that are on the top. So although the net only goes negative in 2075, these scenarios are really relying on massive deployment of carbon removal starting in just about 10 years, right? So there's already in the 2030s a lot of carbon dioxide removal being deployed in these kind of scenarios, even though you don't see that in the net. And that's because the models assume it's cheaper to deploy removal technologies than to deal with actually removing all of our fossil fuel use. So some sectors are difficult to decarbonize, but it's also the faster you decarbonize, the more expensive it is. So it's easier to decarbonize more slowly and at the same time deploy more negative emissions. You still reach 2 degrees. What's the problem with that? So another way to think about this is all these lines and graphs with multiple lines and multiple edges are a little hard. So here's my version of the simpler equation again. What we're saying here is that we have something like continued use of coal-fired power plants or slower removal, that's in the upper left. And we accompany those with biofuel energy with carbon capture and sequestration. That's the most common way to get rid of carbon in our future scenarios. There's a plant in the upper right there, which is in Scotland. And you can see all the trees. What you do is essentially take up carbon by growing trees, and then you burn the trees to generate power while sequestering the carbon. Right? So you're essentially, it's a net sink and removal from the system of carbon. The idea is that you can use that to compensate for a slower removal of coal-fired power plants. In other words, it's the same thing to emit CO2 from the coal-fired power plant and take it up from the biofuel energy, perhaps later in time or in a different part of the world, is the same thing as transitioning to renewables. Right? So is that really true? Well, when I put it this way, might be sort of more obvious that that there are going to be some differences. Let me just, before I go into the differences, say that this is not exclusively the kind of question that we ask for biofuels, but would also be the kind of question we'd ask: is it the same to have continued emissions of fossil fuels and then have a geoengineering scenario where we artificially change the climate of the planet by, say, putting something bright into the atmosphere? Right, which is an illustration of that is shown in the upper right, where things are lofted up on balloons and sprayed up in the stratosphere, and they reflect sunlight and you come out the same. Right? Is it the same? It's an interesting question. So if we go back to the previous one, you know, when you say 2 degrees C equals 2 degrees C, it looks kind of silly because obviously mathematically they are equal. When you illustrate it like this, hopefully it's clearer to you that there are going to be some pretty major differences. Right? And that's clear in that on the bottom, when you have wind or solar, there's no great other impact associated with those. Right? What's the other impact of wind power? Not that much. Right? Some might argue there's some good things. Farmers get extra income, etc. But you look at the two upper pictures, and you can see in the upper left, it's not just CO2 coming out of a coal-fired power plant. Right? The CO2 is invisible. There's loads and loads of pollution that also comes out of the coal-fired power plant. And it's not that using biofuels and capturing the carbon is just a nice, wonderful, clean way to get rid of carbon out of the atmosphere, but right, look at that pile of trees. It's an enormous pile of trees, which means, and that's just one power plant. And so if you're powering a giant portion of the Earth's energy starting within 10, 20 years with biofuels, that means you have to devote a pretty large portion of the Earth's land, arable land area, to growing things to burn rather than, say, to eat. Right? So there's some pretty big trade-offs involved that make the upper line there, coal plus positive plus negative emissions, are not the same as no emissions. And there's been some nice work to look at some aspects of this. I won't go into great detail about this study. It's a study that I like from a group in Germany, where they looked at the impact of relying heavily on what's abbreviated there as BECCS, biofuel energy with carbon capture and storage. And they looked at the pressures of that on water and on biodiversity. And the left side, they tried to optimize for minimal freshwater use, I believe. No, left side prioritizes biodiversity, and the right side prioritizes conserving fresh water. And either way, on the bottom, you have a large fraction of the Earth's land area subjected to much higher pressure on either of those things, like land degradation, et cetera. You have trouble having enough fresh water to use in cities and for irrigating agricultural crops if you're using a lot of it for biofuels. You have trouble reducing eutrophication and too much nitrogen runoff spoiling the oceans and such, because you have to apply a lot of fertilizer to get these to grow quickly. Right, so there are other things that are unrelated to climate which have pretty major side effects by deploying large amounts. Graphic illustration. The upper left was the coal-fired power plants, right? If you're not phasing those out as quickly because you're arguing essentially that you can make up for it later, by deploying lots of biofuel energy and taking that carbon back out. And since, remember that very first chart, it's the cumulative carbon. So from the sake of climate, it doesn't really matter. We could run coal-fired power plants for 20 more years, remove the carbon later, and we would essentially come back to the same point as far as climate change. But that doesn't mean everything else would be the same because, again, the coal-fired power plants are putting out a lot of pollution. So for those who haven't thought about pollution as much, here's a graph from the last published Global Burden of Disease, where they look at the relative risk from all different risk factors affecting premature deaths around the world. And air pollution, exposure to air pollution is number 5 in this analysis, killing just over 4 million people per year from exposure to fine particulate matter, right? So the PM 2.5 means particulate matter is the PM. 2.5 means its maximum size is 2.5 microns, so smaller than a human hair, really, really small stuff. And so the stuff you can see, like in my picture, or from a diesel bus coming down the street, if you can see it, it's probably not so bad for you because you can see it, it's big enough that it will fall out of the air before you breathe it in. But the stuff that you can't see that's so tiny, when you breathe that in, it gets really deep into your body and it causes strokes, it causes respiratory failure, it causes lung cancer, etc. And that kills more than 4 million people per year, with actually every time that the health community revisits these, they seem to find stronger and stronger relationships. So it is not reflected in this global burden of disease from 2015, but the latest studies from the health communities have much larger numbers for both of those, for both PM and ozone, upwards of 9 or 10 million. So that would make exposure to air pollution second only to high blood pressure for leading causes of premature death around the world. It's over 9 million according to the latest data. So why am I going on and on about air pollution? Well, just some statistics, more than 95% of the world breathes air that is above the World Health Organization guidelines. And while that's certainly much worse in a place like India, which is shown down there, people commuting on their way to work can hardly see where they're going. It's true in America also. About 40% of Americans live in counties that exceed the WHO guidelines. In places like India or many developing countries, they don't just exceed it by 10, 20%, but they can be 10 times the recommended guidelines. And about 80% of the energy from around the world is generated by fossil fuels. And it's not a coincidence that both of these things are large, right? Because they're really, much of the burden of air pollution comes from fossil fuels. When you think about the developing world in particular, some of these things are really, really alarming. I have that picture there from India, but here's a headline from a CNN story, right? This is on a really bad pollution episode where breathing in Delhi is equivalent to smoking 44 cigarettes a day. Right? That's pretty horrific. It's horrific also when you think that on average, this is a really bad episode, but on average around the country and over the course of a year, it's equivalent to about 6 cigarettes a day. And I was at a meeting at the World Health Organization where an Indian doctor was pointing this out, who works in a lung surgery unit in a hospital in India, and was saying, his patients are coming in looking like they worked in coal mines or something. And the really scary thing that he said, or the really awful thing that sticks in your head was he would get children to come in with this. And so it's on average equivalent to smoking 5 cigarettes a day, breathing the outdoor air. But that means like every newborn infant is equivalent of smoking 5 cigarettes a day. Right? This is just terrible. So this is the kind of thing that you would never allow people to actually give infants 5 cigarettes a day. But we don't tend to pay as much attention to this. I think that this can be a really critical part of the climate story and of dealing with climate change mitigation, is that at the same time that we deal with climate change by phasing out our reliance on fossil fuels, we'll get this huge benefit by cleaning up the air. And the Paris Agreement actually recognizes that in a sense. Their language is the social, economic, and environmental value of voluntary mitigation actions and their co-benefits for adaptation, health, and sustainable development. So these really were explicitly part of the negotiations, part of the Paris Agreement itself. This is language directly from there. And that's where I took the title. The social value of mitigation activities is something we really should be looking at. But often, as in that European example for the diesel, often that's not the case. Well, that's just not the way it's done. And in fact, when we have our largest international agreements that are put into place to try to deal with this, we have something like the Kyoto Protocol, and that places a price. The European trading system is a good example, emissions trading system rather in Europe, where emissions removals have an economic value, and you can trade amongst different gases, and all of these other things are left out. Right? Only climate that's important. So there's I think a value in having a more complete view. The other thing is, I think psychologically, this is really important. And so some of the psychological studies, these are from journals like Risk Analysis and Perspectives in Psychological Science, they're all cited down there. But there's a large body of literature really showing that people greatly discount uncertain future events when they consider costs and benefits over multiple timescales. We think of things that happen immediately as being important, and we think of things that happen a long way down the road as really just not rising to the top. They're important, but they're not that important when we make decisions. And we discount risks that occur remotely. And most people's view of climate change has been that it's far away, that it's a remote problem. It's happening elsewhere. It's not affecting the polar regions, and it's affecting the Amazon. It's not affecting where we live, right? And so I have an example of that is a survey, the first survey that the Chilean government did in 2015, where they asked people what their opinions were about the most relevant problems. And air pollution, there's a picture of Santiago there, and surrounded by mountains like Los Angeles or Mexico City. Traps pollution, it's really visible, it's tangible. People see it, they recognize it, they know it's important. And all the way down at the bottom of the list is climate. And so this is not a country full of climate change deniers and politicians that say this is not important, but it's just, it doesn't grab people. It doesn't resonate the way other things do. Even things like street dogs come out in surveys as being more important than dealing with climate change, right? Because those are immediate and they're local. And those are the things that really get people. So one of the things we've tried to do in my research group is to look at the co-benefits or side-by-side benefits of air quality from decarbonization and transitioning to low carbon society. So here's an example from the United States, transitioning to clean energy and clean vehicles in a way that's consistent with the 2°C scenario. So that means essentially bringing our emissions from both those sectors, which are two of our biggest sectors. This is industrial use of energy as well. So it's not looking at agriculture, but looking at almost all of our other big sources of emission, bringing these down towards kind of zero net emissions by mid-century. And that's a big request to get people to do that. But if you do that, you can find that there are the maps of changes in premature death from the associated air pollution. And you can see energy, clean energy really cleans up the eastern half of the country, especially places like the Ohio Valley, where there's a lot of coal-fired power plants still used. Clean vehicles is a little more spread out. Some of the emissions interact with agricultural sector emissions, so some of that is in the upper Midwest. But both of these give you pretty large numbers, and some of the numbers are given down there in the text below. Clean energy transition would avoid about 175,000 premature deaths from air pollution by 2030, right? Which is when you're well on your way towards that zero by 2050. Clean transportation, another 120,000 or so. And the climate benefits are given there too, but rightly or not, I would say rightly we should think of 1/10 of a degree or a couple tenths of a degree as being important when we're looking at one sector from one country. That's the kind of thing that is actually enormous progress. But to most people, it just doesn't sound all that incredible. Oh, 1/10 of a degree? We're going to change everything and change temperatures by 1/10 of a degree? In fact, this is some of the arguments we've heard in Congress about things like doing away with the Obama-era Clean Power Plan. Oh, it'll only have this tiny, insignificant impact on global mean temperature, right? The correct answer is it is one part of, the worldwide effort. It's only supposed to have a small impact. But the numbers about things like clean lives saved due to air pollution are a little bit easier for many people to understand. So going back to the psychology, that tends to get most people's attention a little bit more. When we try to put an economic valuation on it, I think we get another important lesson where we've looked, those first two sets of bars there are just the valuation in terms of the benefits to society due to air pollution, called their composition health. That's essentially air pollution. And then the three sets to the right are adding in avoided climate damages as well, a function of discounting, which is how much weight you give to effects in the future versus the present. What's the economic reduced value of things in the distant future? What I think is really important here is that if you just add up the two numbers that are shown there for energy and transportation, you've got around $200 billion for energy and around 100 and 150 or so. You've got somewhere just due to air pollution of avoiding damages in the US of around $300 to $350 billion, right? Or from air pollution. Turns out that nearly all of that air pollution benefit is in the United States. Right? A little bit goes over to the border into Canada, a little bit into Mexico, a little bit spread elsewhere around the world, but most of that is here. Right? So when you have the people in Congress saying like, oh, we don't want to transition, we'll just have this tiny benefit and it's spread out over the whole planet. That is true for climate. For air quality, it's almost all at home. So it's almost all within our borders, and the benefits are actually greater than estimates of the implementation cost for these kind of things, which are more like 100 to 200 billion. So if we save 350 billion just on air pollution, even if you ignore the climate benefits or say they're not that important because they're spread out around the world, you still find that this is a sensible thing to do. This is the kind of thing, in fact, that the EPA has done. This is the example from the EPA fact sheet from 2016, which is now kind of removed, but still archived on the web somewhere. But this was their analysis of the Clean Power Plan that the Obama administration put forward. And the estimate here was that it would provide benefits worth 55 to 93 billion relative to a cost of around 7 to 9 billion. Right? So these were actually the easier things to do. This was not as deep decarbonization, so it's not as expensive. So the benefit to cost ratio is even higher in these. And they took the same kind of approach that they list a bunch of the things that are avoided in the middle, including things that we tend to leave out from some of the economic analyses, right? Look at the bottom one. It's around 500,000 missed school and work days. What's the price on a missed school day? We don't really know how to put a price on that very well. So we tend to leave that out and just put a price on things like the medical costs. But they've got the same kind of thing that I just showed you at the bottom. Just the pollution benefits, which are immediate, right? They happen as soon as you reduce the emissions. They're not a long lifetime for pollution. And they happen almost exclusively within our borders. Even those outweigh the cost up to 7 to 1, right? So we had more like 3 to 1 because we were looking at more complicated transitions. And I think this is really helpful. Do I read that? We're transitioning to low energy demand. This is very useful. Good. I think this is, we tried to do a few more of these analyses to think about the psychology of how to separate these. So in a more recent study, well, just from last year, we tried to really divide these up, and we looked at coal-fired power in the United States, transportation in the United States, and so I could fit these all on one plot with the big caption, coal-fired power in China. And you find that in all these cases, while you get hostility to things like transitioning away from coal in the United States, because we say, oh, well, that's just giving benefits in the distant future and spread around the world. If we divide this up by time scale, long-term and near-term, meaning the first decade or two versus the rest of the century, and national versus geographically remote, then at the scale of kind of a big continental size almost country like the US or China, The benefits that are long-term and geographically remote is that kind of orangey one. And that's really a small portion. So it doesn't really make sense that we should be arguing about, well, do we really want to sacrifice at home and make this big change at home for the benefits of the rest of the world in the lives of our children? No, that's not where most of the benefits are. Most of the benefits are in that yellow one, which is near term and in the nation that takes action. So obviously this doesn't work for, Switzerland or somewhere really tiny, but for the scale of, say, Europe or China or India or the US, most of the benefits you get from these kind of transitions are really local. They're within your borders and they're in the near term. So they're things that citizens can really see. And so that can be a more attractive way to get these benefits to resonate with people. There are exceptions, right? So one of the exceptions is controlling a leakage from natural gas systems or methane from agricultural systems. And in those cases, only about 5% of the benefits are national. Because it's not a traditional air pollutant like smog or particulate. So this doesn't always work, but in cases when it does work, I think it could be quite powerful. I want to show you results from one other study, which is looking at the question of not just a US transition, but really going back to that graph I showed, or the almost like a rebus, filling out the coal plus biofuels equal wind, right? Is that the same? Well, so we have the kind of scenarios that I showed you before, and that's what's illustrated on the left. We take a 2°C scenario with the net emissions are shown in that solid purple line, and it's the net as a result of the positive and negative, which are shown in the dash. And then we make up another scenario where we essentially follow that blue line there. We essentially follow the same total CO2 emissions, but we do so without having any negatives. We just reduce the positives to essentially follow the same kind of curve. So in other words, we're phasing out use of fossil fuels more quickly and more deeply along the way. And then we can see what difference does that make. That also turns out to be about the same as going from 2 degrees to 1.5 degrees. So we have a global climate and composition model. We develop these scenarios over time. We did this one every decade to look at what happened. We charted the course of future climate. It's not terribly different, sort of by design, right? You're getting the same cumulative CO2 emissions, so the climate change comes out to be very similar, but it is quite different for pollution. So we have ways of looking at pollution, and I won't go into great detail, but if somebody has questions about this later, here's an example of how we represent pollution over East Asia in comparison to observations. We have kind of some high resolution, detailed mathematical tricks that allow us to really pinpoint individual cities. Because this really matters. It doesn't make as much of a difference if it's polluted, say, somewhere over the ocean where nobody's reading it, right? As it does right on shore in a coastal city. So Shanghai, for example, you want to get it right where Shanghai is. You don't want to get it over that general area. We've done that. We're able to reproduce observations with pretty small biases. And so then we can look at the effect on public health at very high resolution going forward through time. And then we get results like this. And so this is a little hard to read any of the details of because we're trying to show the whole planet. That's why we have to use some kind of mathematical tricks to get high resolution, because it's challenging to represent the whole planet over a century and get enough detail to do public health analyses. But what you can see here is you can pick out, well, if your eyesight's better than mine, you can pick out, but with me, I need glasses just to see this, and it's like a foot away. But you can see, Atlanta, and you can see Denver, and you can see Madrid and Paris, and you can get values for individual cities around the world. And that goes back to this psychology. What do people respond to? People don't respond to things that are amorphous, that they're providing benefits spread out in space and in time. And this is saying these benefits are from pollution. So they're happening in the near term as you're getting rid of fossil fuels. And we can tell you how much how many lives it's going to save in your city. And so this is a graph from the paper, but like many scientific papers, it has a long supplement with tables of every big city in the world. And you can go and look up exactly how many people's lives will be saved in New York or Paris or Cairo or anywhere you like. The cumulative impact of all this is about 153 million fewer deaths by phasing out that pollution quickly. And the majority of those are in the near term, right? Because in the scenarios that you're comparing with, right, this is really getting rid of fossil fuels very, very quickly versus doing it more slowly and then making up for it later with biofuels, with carbon capture and storage, right, with negative emissions. And so the difference is, you know, later in those scenarios, you still don't have coal. Nobody thinks we're going to have lots of coal in the second half of the century. But in the first half, we either bring it down right away or we take our time and then make up for it later with negative emissions. Making up for it with negative emissions gives you the same CO2, same climate effect, but 150,000 more deaths along the way from air pollution. So that's something that's saying that 2 degrees C, all 2 degrees C are not created equal. They're in fact quite different. And I think this resonates with people. Here's an example. After our study came out, you know, the Washington Post ran a story on this with one of these pictures of lots of pollution coming out. And one of the things they highlighted, you know, an overlooked benefit to greatly lowering carbon emissions worldwide. In addition to preserving Arctic sea ice, reducing sea level rise, and alleviating other effects of warming, probably saved more than 150 million lives. Right? So this does tend to catch people's attention. This is the coverage in a place like the United States, but what I found even more interesting was coverage in places that are often not reporting so much about climate change news. In particular, developing countries often argue, I think quite fairly, that they did not cause climate change. They should not be the ones to decarbonize first. We shouldn't be pressuring them to clean up. We should be cleaning up, and developing countries should be given a break. Right? Well, developing countries are more polluted, so they get much bigger benefits than we get by cleaning up. And so here's some of the stories in Pakistan, for example. Right, 11 million premature deaths. They went and they added up all the cities in Pakistan that we included in our table, and they list that. And that it really suggests that that psychology of saying locally, this is where the impacts are, really gets people's attention. So we have the left one from Pakistan. The right one is an example from India, where they list the top 10 cities from our paper. And they do so because well, some of those are in Pakistan, but 9 of the top 10 are in South Asia. They're on their list. So that does get people in areas of the world that are not really, you know, India is still saying, well, they are saying we need to push renewables and we have aggressive plans to put in solar and such, but they're also still building coal-fired power plants. They say we need this because this is the cheapest way to develop. So this is convincing them, hopefully, starting to, that, you know, that it's in your own best interest not to follow the road we did. Yes, it was cheap and we got ahead by doing this, but we killed a lot of people along the way. We had terrible pollution problems in the 70s and 80s and such in Europe and Japan and the United States, and you don't have to do that just because we did. In fact, you already have worse pollution and you could clean it up. So I thought this was quite interesting. Also interesting to me to see that, you know, while the US uses Fahrenheit and everybody else uses C, and you think the US is the weird one, the Indians have a whole different unit for numbers, which I never even heard of. So these are reported in lots, which brand new, who knew? Not just us that have weird things. Anyway, so there's a few examples there, right? I showed our study of the US transitions. I showed the EPA's analysis of the Clean Power Plan. I showed our analysis of worldwide decarbonization. And these really help us clarify the overall, not just the climate impacts of these kind of scenarios. The problem with these is that they all require intense amounts of supercomputer time. These are not things that most people can put into practice. They don't tell you what any other policy you might do. So, you know, if we don't put in the Clean Power Plan, but we do something a little bit different, what happens? What if we don't follow the exact transportation scenario we use, but a different one? Well, you'd have to contract some group like the EPA with a lot of scientific capacity, or some scientists like a research group at Cornell or Duke or somewhere, give them a bunch of money, they can buy supercomputer time, you wait several years and you might have an answer. That's really not very useful for policy. So one of the other things I think is quite important is for us to try to generalize these kind of things and make it a little easier for people to figure out how they can more broadly apply these kind of estimates. What are the overall effects of reducing any given kind of emission, right? Every motor vehicles, power plants, industries, they all emit a variety of pollutants. We look at each one and we add them up, we can figure out what the overall benefits are. So that's one of the things we've been working on. This is one of the examples from the IPCC report where we have ways of evaluating climate impacts, and those are pretty well established. This is what's used, for example, under the Kyoto Protocol or the European Emissions Trading System. You look at metrics based on radiative forcing, which tells you what the climate change will be, and you figure that's a good proxy for everything going on. What we have tried to do in some of our work is to highlight that many cases like power are affected by all these things. We don't care about climate change because we want the temperature to be some particular value in and of itself. We care about it because warming brings adverse health impacts, and it damages our ability to grow crops, and it damages our infrastructure with sea level rises. Air pollution does all the same things. So we just calculate things by societal well-being rather than by the pathway by which you get there. And that's one thing that's typically hasn't been done, or at least hasn't been done all that well in American US government analysis. What we have used are economic analyses of the impacts of emissions via their effect on climate change alone. And those include what climate change does to, we have to of our labor at outdoor jobs because it's too hot. We have to spend more on air conditioning, right? That seems like an odd thing, but that's actually the biggest thing in some of the models. Agriculture, some of the models have very crude representations of that as well. So here's one of the models used in the first US government analysis of what's called there the social cost of carbon, the SCC. It became an official part of US government rulemaking under the Obama administration. And you can see that the total value here, we assume that every ton of CO2 emission caused about $6 in damages. But that's the result almost exclusively of more air conditioning costing about $8 and losing a lot of that damage because supposedly agriculture likes more CO2 and you actually get better crop yields. I don't think most of this holds up very well. I find it quite implausible that the biggest economic impact of climate change is just that we have to run more air conditioners. So I think there's a lot more, and this is, to be fair, from the 2010 US government analysis, the 2013 version, which was the last one before the Trump administration kind of threw this kind of work out. Use slightly more sophisticated models, but my point is that in general, things like limited access to food and water and health services, things like mass migration, damages as a result of conflict, right? I put the Ukraine conflict there because that's really about the only one I can think of that hasn't been linked to climate change, right? So that's why Ukraine with the line through it, right? The war in Syria, the war in Sudan, migration from Central America. A lot of these things have been linked, you know, to what extent is debatable, but linked to climate change. All of that kind of stuff we are leaving out, right? Increased storm damages, they're hard to predict, so we leave them out, right? So we're really underestimating a lot of the climate damages, and we're leaving out everything that's not related to climate. So this is really one of the things where we need a bit more analysis. What we did going back to our study of a faster decarbonization or a deeper decarbonization, going from 1.5 to 2, mitigation costs in those models that generated these scenarios find it's an extra 1 to 2% of GDP, which is a nice way to put it because it sounds small. GDP around the world is a very, very big number. So 1% of GDP is an enormous amount of money, but it sounds easier when, you know, it sounds more doable when you say it's 1 to 2% of world GDP. The OECD has done a lot of analysis on what the effects of air pollution are, and like some of the things I just mentioned for climate change, air pollution makes labor productivity go down. Air pollution makes medical spending go up. Air pollution makes kids have to stay home from school, and therefore their parents can't go to work and stay home to take care of their kids. And they have come up with valuation of air pollution, and so we took our air pollution results and compared them, and the air pollution benefits alone give you about 0.6% increase in GDP. So that offsets somewhere on the order of 30 to 60% of the cost. The other interesting thing about it is this is only those benefits that are really reflected in the market, right? Because that's the way OECD did their analysis. Only things that are actual, you can watch the transaction of money changing. This is not placing any value on all these avoided deaths, right? So this is definitely at the low end of estimates. And using things like the US government social cost of carbon, the reduction in climate damages is only about 0.2%. So this is the limitation of doing an economic analysis. If you only include climate, you're actually leaving out what might very well be the bigger term, which is the benefits from improving public health. So this leads me to the other simple, or perhaps this one is the not so simple equation. Can we just generate equations where we can provide to policymakers and say, let's calculate the overall benefits. They're a function of what climate impacts there are. They're a function of what public health impacts there are. If we can relate them to other things like agriculture and labor productivity, et cetera, include all of those things. And what we get is an equation that has all the major emissions, CO2, methane, nitrous oxide, carbon monoxide, et cetera. And each one has a coefficient telling you what its value is, right? And then if you had that, you could look at any policy options and just say in general terms, well, which one gives me the most benefit? Let me figure out how much it costs to do this. Let's figure out if it's worthwhile. Or should I do the option A or B? Well, let me figure out how much I get from each one. So here's an example of we've run our models, tried to evaluate these coefficients, the C1, 2, 3, et cetera, for every pollutant. And then we look at those and apply those to specific cases. We've done things like driving motor vehicles, electric versus gasoline, et cetera. Here's one. I don't want to take too much time, so I'll just show one, which is the example of the cost of generating electricity in the United States. And when you look at this, this is how much the utility companies pay to build new power plants. And the cheapest thing on here, it's essentially a tie, gas and wind, but gas is dispatchable anytime you want. So unsurprisingly, if you look at what US utilities have been doing in the past decade, they've been building more gas than anything else, right? That's what I would do too if I was in charge of managing the books in a public utility. But this isn't, of course, the only thing that happens. And so if you take that equation and you multiply the emissions associated with each type of power by the coefficients, you can see what the cost is counting for environmental externalities, for public health and for climate. And then you'd see that it's preposterous to ever build coal because that's so damaging. But you also should probably not be building so much gas, right? The gas is damaging our future, our planet, by causing climate change because it emits CO2, and it's also causing air pollution, and that's important as well. And so we've tried to put these kind of things out there, lest you think this is purely an academic exercise. Here are a couple examples. The Chilean government also put this kind of thing into place. A 2014 law covers stationary sources, and there's a price for every stationary source, meaning essentially not motor vehicles, but power plants and industry and such. There's a price per ton of carbon, $5 a ton. And then there's a price for pollutions that lead to air quality impacts. And the bottom section, the local pollutants, is based on what kind of population lives in the area where you're emitting it. And so two examples are down there from one of Chile's most populated provinces, give you the high numbers, and one of the less populated would give you the low. And it varies by about a factor of 100 or so, right? So this is essentially saying, if you want to run a big industry, you're going to pay something for your damage to climate, which doesn't matter where you are. But you're also going to pay something based on how many people are going to have to breathe what you're pouring out. And that's based on how close you are to where they live. And so this is avoid the pitfalls of, say, the European promotion of diesel, right, by acknowledging that there are multiple effects, that multiple things that come out of these emissions really matter. And to get an equation even more like the one, idealized one I showed, here's the equation for taxes for new vehicles in Israel. And essentially they have something very similar to what I just showed you. There's a coefficient for every pollutant, and the value is actually all the way to 6 digits. I'm not quite sure how they feel it's quite that precise, but I guess you have to set something. And it has all the major pollutants that cause public health impacts, and it has something like CO2, which causes no public health impact, but causes climate change. And then you get an overall grade on your taxes, or on your car's performance, and the new vehicle purchase price, the tax on a new vehicle in Israel is very high, or can be very high. So they've got a lot of wiggle room. And so if you look at this and your grade comes out in, say, the 200s, your effective purchase tax rate can be 75%, right? So that's a big deal. If you were buying a vehicle that costs, say, $30,000, and you have to pay an extra 3/4 of that, right? That's more than $20,000 extra. That's a lot of money. Whereas if you buy the same $30,000 vehicle, but it gets a good grade, it's down around 100, then your tax is 25%. Right? This was actually so successful that they put this in place, and within 3 years they had to revise all the grading system because nobody was buying any of the expensive ones. Right? So this is really a way that you can incentivize behavior. You can incentivize behavior in such a way as to get both the things you want, or all the overall societal benefits. You get cleaner air and you reduce driving of climate change at the same time. Right? This doesn't mean these things are easy to do. I like to show this slide, which has the penetration of electric vehicles in different countries around the world. And what you see here is that there are 2 big outliers. The Netherlands and Norway, with far more share of electric vehicles sold than anywhere else, right? And those places, you know, like Israel, they have taxes and they have various incentives, but anybody have any ideas of anything unique about the Netherlands and Norway? We should put that as a question for afterwards. All right, a unique thing about the Netherlands and Norway, or something different compared to almost all of the other countries here, is that neither the Netherlands or Norway produce cars, right? So how can you get these laws into place? Well, it's much easier when you have no domestic opposition. So the main difference between Norway and Sweden is, I would argue, not that Sweden is a less progressive country and Norway is really good about taking care of the environment and Sweden isn't, but that Sweden has Saab and Volvo and Norway doesn't. Well, and that makes a big difference. And so you're still trying, I mean, the point is not to say that these things are easy. Even if we know what we have to put in place, there's still an important resistance to overcome. I want to show you one last thing, just because I'm really excited about it. It's something we've been working on at Duke. To try to put into place a new kind of novel interaction that we can put a price on. And we have a cooperative program with the Indian Institute of Technology in Gandhinagar, outside Ahmedabad. And they took us up to the roof to proudly show off their solar panels that they'd installed on the roof of their institute, which seemed great. And we thought it was kind of interesting that they were, in fact, when we first got up there, so filthy you could hardly tell that they were solar panels. So you could see where we wiped off around them and written in there IIT and the date and such. This is really a big deal. It got us thinking, oh, there's a lot of pollution in these places. Pollution is not just bad for people, but I wonder what it does to solar panels. So we built, had some of the engineering students built these little prototypes like this, where there's 2 identical panels just deployed on some PVC pipes, really cheap. You make these. This is deployed on the engineering building at Duke, and you go and you clean one every day and the other one you don't clean. So North Carolina's not India, pretty clean comparison. But you can see on the left, you know, the ratio is on the right-hand axis, and it starts at 1 and it stays 1 for the first many days there. And then we had a bit of pollution come in from some fires up in the mountains or whatever. Once the dirty one is not getting as much sunlight through as the clean one, then the power generation really starts to diverge. So we're trying to set up a network of these, really figure out how much the deposition on the solar panels affects production, put that into our model, which is already modeling all this pollution, and see what it does. And we published our first paper on that, looking at some of the dirtier areas in the world, where places like China or India, you can be losing anywhere between 15 and 20% of your solar power production. So not only would it be in their interest in a place like India to clean up their fossil fuel power sources and perhaps not keep building coal-fired power plants, but it would actually affect the performance of all the renewables they're building. They're kind of, one part of the government is in some sense undermining another part by installing more fossil fuel capacity while another part puts in solar. It just doesn't really work. And places do have cleaning. You could see those men on the left there, manual cleaning, and there's a fair bit of water used in that. So it's expensive, it's heavy on water requirements, and the overall loss from pollution, we estimate, is another $1 billion or so a year. So yet another thing which is left out. All these benefit estimates are quite conservative. So how can we try to maximize the overall benefits? Well, we need to weigh policies in light of their impacts, not just on climate, but climate and really the overall sustainable development goals agenda, which is healthy air, which is healthy life on land, fresh water available to people, etc. There's a lot of things that are affected, whether we consider or not, they will be affected by our climate policies. We need to include the economic externalities, right? If we incorporate market costs, we will not just base our analyses on what is the least cost pathway to get there, but we'll compare how much we're spending to make the transition with how much we get in return. And that's really not what is done in generating future scenarios. And we need to raise public awareness. I think that can really help. One of the things we showed in the report you heard about last seminar, the 1.5 degree report, was that achieving those is really difficult. And we also know that achieving the World Health Organization's clean air guidelines, that's really difficult, right? If 95% of the world doesn't have them, that's a big ask. But I think we need to tell people that achieving both of the low climate targets and the air quality guidelines is really challenging, but it means improved public health, increased labor productivity, all other businesses, in other words, benefit, improved crop yields. I didn't go into that, but that's quite clear as well, improved solar power capacity, et cetera. We can quantify these and really help people chart out not only how to get to these, but how to optimize getting to these low targets. Thanks very much, and I'm happy to have questions. Oh, it's microphone.
So I didn't understand your carbon capture argument earlier in your talk. So you're planting trees to draw down carbon, that's good. But then you're burning them to generate
Power.
electricity. So how is there a net gain out of that?
So this involves a technology that is not commercially deployed at present, but you burn anything to get power. And if it emits carbon, you can capture that carbon and then bury it underground. And so if you do that with a fossil fuel, then you just turn it from a carbon source to zero. But if you do that with something that sucked up carbon in the first place out of the atmosphere, you can actually get net negative, in principle. Right? In practice, this is not done.
I was wondering what the geological impacts could be of BECCS.
Geological.
Yeah, like burying it underground.
Right. Well, I think and this is not an area that I'm super expert in, but I think that there is a fair amount of experience burying carbon underground for industrial purposes, either to store, well, compressed gas, say, or to push carbon underground to push out more oil, ironically. I think unless you had enormous amounts, you might cause earthquakes the way fracking can do. But in general, there's a large capacity for that. But I think the geological question that worries most people is knowing how much will eventually leak out and how much might leak out over a long period of time. And then the practical question, which you didn't ask but is also important, is that you have to get to the carbon from wherever you produce it to the geological areas that are good to store it. And those are not distributed evenly over the planet. For example, there's a lot more in the middle of the country in the US than the East, where we use most of our power. So in order to do this, you'd have to build an enormous network of pipelines. And we've all seen how readily the public is opposed to pipelines. So it's a really difficult problem, technologically and geologically.
So on your slide with the emissions and damages with the energy choices, I noticed that there was just small amounts of damages with wind and solar. What exactly emissions related damages are those?
Sorry, I missed the beginning. Could you start?
So you have this one slide where it has like the energy choices and
Right.
then the emissions and the damages related. I noticed that like the solar and wind also had like some emissions related damages. While it was minimal, I was just curious what they were.
Yeah, so that is in the construction and transport of the, say, the solar panels or the wind turbines to where they're used. So it's just trying to get more of a life cycle analysis, because you do have to, there's some mining to get the materials that go into the solar panels, and then you're building these big wind turbines, but they're quite small. So they affect the result minimally, but they're not all that important.
I was wondering about, since you have all like the economic scenarios, is there like, do you know if there's like a large group of people like, it's like economic. I can't think of how to say the name of the people that do economics. Are there large groups of people like focused on, like in the economics world, like focused on the environmental issues that relate to economics? Or is it like a very like select small group of people?
Are you asking if the general public is more focused on environment?
No, if there's people in like the world of economics that like, are there large groups of people concerned about
Right.
These issues?
Yeah, I would say it's a relatively small group of people. I think there's a growing appreciation. I mean, I probably shouldn't, criticize, like one of those models I was saying is really primitive and such. The developer of that was given the Nobel Prize in economics last year, right? So that, I mean, there's an appreciation that this is really valuable, but it's not a big group of people. And there's a lot of difference in that, for example, the American economic community tends to do this rather differently than the European community. And it's a little bit odd that there hasn't been kind of a greater effort to think through how to deal with a lot of the things that I mentioned that are poorly dealt with and bring all of our expertise together. So unfortunately, it's a small group, and I think it's got a long ways to go.
Hi. With so much of the impacts that you were mentioning, specifically on human health due to the air pollution, I was wondering if you're seeing any changes in the medical industry, whether it's hospitals, education, or healthcare, relating to where people live and if that's affecting their healthcare or how that's going.
What we have seen is, I would say that the healthcare community, if I understood right, is what you're asking, that the healthcare community didn't regard this as an important issue just even, say, a decade ago. And the World Health Organization, for example, didn't until, I think, 2010 or so, even really include air pollution amongst its list, other than in urban areas. They thought, oh, maybe it's important. And it's only really because we've got better satellite data, better understanding, that that's become clearer. And I think there's been a very good response in the medical community. There are groups within the American Medical Association dedicated to informing patients that, this is part of what's making people ill, right? Because it's always disconnected. But somebody dies from a heart attack or stroke, and you don't think somebody died from air pollution. Nobody's death certificate says died from air pollution. It always says something indirect. But I think the medical community is really on board now, and they are really trying to educate people that air pollution is a crisis and that climate change. And so I didn't show that, but as we progress to warmer and warmer temperatures, the average temperature doesn't do very much, but the heat extremes go up too, and people are quite sensitive to those. And so we are seeing a growing risk from climate change as well as from air quality.
In regard to your point, like kind of talking about how developing countries should help clean pollution, what would you suggest are the best ways to develop for developing countries to clean that pollution? Like, because technologies like carbon capture are expensive to maintain, and then also, like, do you think developed nations have any responsibility in helping to do that?
Yeah, so good questions. I mean, I think that the standard approach in developing countries is often to say, let's follow the path of the advanced countries. And I think for something like motor vehicles, that is not a good idea. Because what we did was, and essentially what we did for motor vehicles and for coal-fired power plants was say, well, there's a lot of pollution. Let's clean up the pollution and let them keep pouring out all the CO2. And so now we realize that, you know, it's not the 1970s. We don't need a Clean Air Act just to target pollution. We need to target CO2 at the same time. And so the way to do that is for them to go straight to things like electric vehicles. And so I think there is some recognition of that, partially because the big Indian conglomerate Tata makes an electric car. They have got the government to pledge that they will no longer allow sales of internal combustion engines after 2040, right? And it will be entirely electric. And that's the way to do it. Then you've gotten rid of both things at the same time, rather than first you put an end of pipe technology and then you change the fuel. You just go immediately to the new fuel. I think we should be helping them because if you think back to that first chart, total CO2 determines temperature. Well, most of the total CO2 has been used up by us emitting since the Industrial Revolution, the Europeans and the Russians and the Americans and Japanese and such. So I think we do have a responsibility to try to help other countries do that. But I think they need to transition. And one of the interesting things is maybe they actually have a little bit more impetus to do that, right? India announced a phase out of internal combustion engines well before most of the West. And one of the first actual automobile company, the first large company that announced they won't make any more internal combustion engines is Volvo. But interestingly, they announced they would stop making them after they were purchased by a big Chinese company. And the Chinese would like to have clean air, right? That's a really big deal in developing countries. So maybe that will really encourage them to actually shift and get out ahead of us.
I'm wondering what you think about in terms of incentivization with carbon tax, what happened in France when everybody protested due to the carbon taxes kind of targeting the working class who need to drive to work and use fuel.
Yeah, that's a really good point. I mean, these things are really difficult to put into place. And in many places, like most of the United States, it's kind of politically toxic to even mention we put a tax on something, right? But I think what we need to do is both be kind of clever about how we do it. What we do already is we have a lot of fees on things. And so we can tweak the existing fees, which doesn't necessarily promote such a backlash. For example, in North Carolina, the electric cars are catching on slowly. And so the state of North Carolina said, oh, we're not getting as much gas tax as before, so let's impose a new vehicle fee on electric. And they're thinking, really? This is your way of encouraging electric vehicles? And so what they could do is, since they already charge us based on property value of the vehicle, they can just adjust that. And I think that would be much more palatable than saying, we are going to triple the tax on gasoline-powered vehicles. That seems punitive. The other thing is, you're right, there are other issues that are tied up in social issues. And what has been happening in, so Germany, for example, has unfortunately, as they decided to phase out nuclear, has been using lots and lots of coal. And they are now proposing, Parliament just passed earlier this year, so in January, that they would get rid of every bit of remaining coal within the next few decades. So that's something like 80 power stations or something. It's a lot. But at the same time, and this is the noticeable bit, or the notable bit, they said they would put 45 million to retraining. And that's really, what we get in the United States. Oh, the war on coal is a way to punish Appalachia. No, you really need to be supporting these people. And to go back to North Carolina, there's a great example. When the US really pushed people out of tobacco farming, right, the way that they lessened the hardship of that was giving farmers incentives to grow other crops, rather than saying, we're putting a tax on every bit of tobacco you grow. Here's an incentive to grow something else. And so I think we need to we have to recognize that we are pushing coal out of business. Right? And so there's a consequence to that. And if we don't mitigate that and make it clear that we really intend to make those people's lives, not suffer so much from this kind of thing, it won't go through.
Hello, you mentioned the Israeli green grade vehicle tax, which included like evaluations of every pollutant rather than just carbon. Have like similar taxes been applied in other industries? And if so, have they been successful? It seems like a very interesting way to combat climate change and pollution and other.
Yeah, so this is the kind of thing that has traditionally not been done. That traditionally we treat things as separate problems. And so we had, for example, in the US, in response to acid rain, we had emissions trading for NOx and SOx, and there was a price put on emissions of air pollution. But climate left out completely. And then we have the Regional Greenhouse Gas Initiative, which is climate but no air pollution. And California has emissions trading now, and Quebec does, and those are systems that are only climate. And so in general, people have still not taken these kind of attitudes, and they haven't linked across multiple benefits, except for a few very progressive places like Israel and Chile. So yeah, I would like to see more of that, but it takes a while.
Okay, let's think through again.